No talking under my breath. Oh, okay.
All right, we're going to get started. We're a couple of minutes late, but that's okay. They're well worth the wait. We've got Adriana and Reese here. They're going to be talking about when things go sideways, how to troubleshoot the OpenTelemetry Operator. So, ladies, I'll leave it to you.
Thank you, Courtney. Hi, everyone. Welcome to our session, When Things Go Sideways, Troubleshooting the Operator. And first, I'd love to introduce my co-presenter, Adriana. Yes, I got that right.
Oh. Hello. Oh, this is going sideways. Come on, seriously? Okay, here we go. Let's see if this, okay. Yay, it's working, okay. Hi, my name is Adriana Villela. I'm a CNCF ambassador, HashiCorp ambassador, blogger, and podcaster. I do have a day job. I am a principal developer advocate at Dynatrace. I literally joined a week ago. I specialize in the OpenTelemetry and platform engineering spaces, and I'm one of the maintainers of the OTel end user SIG alongside my awesome co-speaker Reese. And by night, I like to climb rocks, so much so I sprained my ankle recently, fell off a bouldering problem, and can't boulder in Salt Lake City this week, which makes me super sad. But you know what makes me happy? Capybaras.
Hello, my name is Reese. I'm a senior developer relations engineer at New Relic. And like Adriana just mentioned, we work together in the OpenTelemetry end user SIG, where we're focused primarily on working directly with end users and kind of closing that feedback loop between end users and contributors to help improve the project and drive adoption and implementation. So if you have an interesting story you'd like to share, we would love to hear it. We do interviews, and we work with the other SIGs to do surveys and such. I love horror movies, landscaping, started training jiu-jitsu, and I love it. You can usually find me eating, or if you want to find me on socials, you can do so. It's just Reese's Bites, Onyx, and Blue Sky. And so with that, how we've organized our session for you today is we're going to start with an overview of the OpenTelemetry Operator. Then we're going to talk about how to install it, how to deploy the collector using the operator, and how to use the operator to inject auto-instrumentation into your Kubernetes pods. And along with those, in those three sections, we're also going to cover commonly encountered issues, as well as some troubleshooting tips on how to resolve them. And finally, we will wrap up with some key takeaways, and we'll also share reference materials and the repositories so that you can try things on your own. OK, so what is the OpenTelemetry Operator, and what does it do? So if you already have an application running in Kubernetes and you're exploring using OpenTelemetry to get insights into the health and performance of your cluster and application, you might be interested in the OpenTelemetry Operator. It's primarily responsible for two things. The first is managing the deployment of your collector and making sure it's configured correctly in your cluster. It also manages configurations across a fleet of collectors via OpAMP, which is a network protocol for remotely managing large fleets of data collection agents. Now, the second thing it's primarily responsible for is injecting and configuring auto-instrumentation into your pods. And Adriana is actually going to go over that more in depth shortly. So let's learn what we need to install the operator and how to do so, and then we'll look at some commonly encountered issues and some troubleshooting tips. OK, so first, this might seem obvious, but before you install the operator, you must have a Kubernetes cluster that you can install into that's running on at least version 1.23. You can spin up a cluster on your machine using a tool like Kind or Minikube, or of course, a cloud service provider hosted cluster. Next, if this is less obvious, you must have Cert Manager already installed on that cluster. This piece manages your Kubernetes certificates and makes sure that they're valid and up to date. To install both the Cert Manager and the operator, you can use kubectl or Helm. And we've also included commands that you can reference for both options in the slide deck. So for kubectl, it's pretty simple. There's essentially just these two commands that you use. For Helm, first thing to note is that version 3.9 at least is required. And this step will take a few minutes. Once that's done, you can install the operator. Note that in either case, you have to wait for the Start Manager to finish installing before you install the operator. Otherwise, the operator installation will fail. Oh, yep, 1, 2. OK, so once you have Start Manager and operator installed and set up a new cluster, you can deploy the collector. Who here is familiar with the OpenTelemetry Collector? Oh, how about half? OK, that's pretty cool. So we'll just do a brief refresher on what this is. It's a really cool and versatile component of OpenTelemetry. It ingests data from a variety of sources. It transforms that data based on how you've configured it. And then finally exports that data onto one or more backends that accept data in the OTLP format, which is OpenTelemetry Protocol. It's also supported by additional functionality called connectors and extensions, which are optional. OK, so the operator has a custom resource that is used for managing the deployment of the collector called OpenTelemetry Collector. So a few things we want to point out with this sample OpenTelemetry Collector resource. One is that there is a version. This one we're looking at is v1 beta 1, and that will matter for reasons we will go over shortly. And you can see that the kind is OpenTelemetry Collector. And then depending on how you are instantiating it, there are many configuration options for this custom resource. But the basic configuration requires two things. One is the mode, which can be one of 4 deployment, sidecar, daemon set, or stateful set. And then the other thing you will need is the config attribute, which may look familiar to those of you who know about the collector, because it is the OpenTelemetry Collector's YAML configuration. One more thing you want to call out is if you have specified sidecar mode, there's some specific things you're going to want to take note of, which we'll go over as we cover it, which we'll cover as we go over it. So for this case, you will want to add an annotation to your deployment YAML, which we have highlighted here for your reference. Oh. OK, so what happens when you deploy the OpenTelemetry Collector CR and things go sideways or don't go anywhere at all? First, check whether your resources were deployed correctly. When an OpenTelemetry Collector resource is deployed, the following objects are created in Kubernetes: the OpenTelemetry Collector, collector pod, and if you have specified non-sidecar mode, look for deployment stateful set or daemon set resources with the following name structure. And for sidecar mode, you should see a collector sidecar container being created in an application pod named OTC container. Next, you'll want to make sure that a config map was created when, and the thing to note here is for sidecar mode, the collector config is included as an environment variable in the OTC container. And finally, if you have enabled the target allocator, which is a whole separate topic, that will also be included here. So just be aware. But there's lots of interesting stuff on the target allocator that we're not going to cover here, but it's cool. OK, so when you deploy the OpenTelemetry Collector resource, make sure those objects are created. So first, check that the OpenTelemetry Collector resource itself was deployed. And then next, check your config maps. When you deploy the collector using the OpenTelemetry Collector resource, it creates a config map that contains the configuration of the collector. So confirm that the config map was created in the same namespace and that the configurations themselves are correct. Why do all these words have so many syllables? We also recommend checking your collector pods, and depending on the collector mode that you have specified, you can use the appropriate one here for non-sidecar or sidecar mode. Also check the collector CR version that you are using. So earlier I called out that we were looking at a sample collector CR that was version v1 beta 1. There is one more version, and that is v1 alpha 1. So the first thing to note is that the config sections between the two API versions are different. The config value for v1 beta 1 is the actual configuration of the collector, meaning that the key value pairs are part of the CR configuration. But for the v1 alpha version, it's actually one long text string. But keep in mind that the text string still needs to follow YAML formatting. Another thing to note is that if you're using v1 beta 1, you can't leave the collector config values empty. You must specify either empty curly brackets, braces for scalar values, or empty square brackets for arrays, which is not necessary if you're using v1 alpha 1. You also want to check the OpenTelemetry Collector base image that you're using. By default, the collector CR uses the core distribution of the collector, which is a bare bones distribution of the collector and comes with just a base set of the components. If you want access to more components than the ones offered by core, you can use the collector's Kubernetes distribution instead, which was made specifically to be used in a Kubernetes cluster to monitor Kubernetes and services running in it. Alternatively, you can also build your own collector distribution. And we've highlighted here where you can set the base image version. OK, I have a couple more things to note. So if you're using a backend vendor to ingest your telemetry, you'll likely need to configure some kind of access token or license key. So make sure that you're using the right one for the account and the backend vendor that you are sending this data to. And also be mindful that you will probably want to prevent that information from appearing as plain text. So you'll want to store it as a secret, either using Kubernetes secret or a secrets provider. And then finally, if you're not seeing data in your observability backend still, make sure that the exported endpoint for your backend is configured correctly. And with that, I'm going to pass it off to Adriana.
Thank you, Reese. OK, so we've learned about the collector component, management component of the operator. Now we're going to learn about zero code instrumentation component of the collector. Now, before we talk about that, let's level set a bit and define what we mean by instrumentation. So instrumentation is the process of adding code to software to generate telemetry signals. Awesome. And if you're familiar with OpenTelemetry, there are two types of instrumentation. We have zero code instrumentation, also known as auto-instrumentation, which means that the instrumentation is done for you. You do not have to touch the code. So basically, you have bytecode or shims will intercept the code at runtime or compile time and insert those traces, metrics, or logs for you on your behalf. No code touchy required. There are several languages that are supported for auto-instrumentation in OpenTelemetry, including Java, .NET, Python. For more information, scan the QR code at the bottom of the screen on auto-instrumentation. Super handy stuff there. Now, on the other hand, we also have manual instrumentation, which, as you would imagine, requires that you, the developer, insert those traces, metrics, and logs into your own code. Awesome. So as I said, the operator does that nice auto-instrumentation for you, and it does that by injecting auto-instrumentation into your application pods, courtesy of a lovely new resource available called the instrumentation resource. Now, let's run through what that means, all this blob of text here. So first of all, take note of the fact that our API version is opentelemetry.io/v1alpha1. Unlike the collector, which has two versions of that API, there is only one version of the instrumentation API, and our instrumentation, our kind is named instrumentation. The other thing of note is we have this section called env, and this is where you define your OpenTelemetry environment variables. And for your convenience, I have included this QR code where you can find all of the applicable OpenTelemetry environment variables. Now, in addition, we have a lovely section here called exporter, and this is where you specify where you're sending your telemetry data to, usually some sort of OTel collector residing in your Kubernetes cluster or maybe outside. And by the way, if you want to know what each of these fields does, you can scan this QR code. It's got the API reference. So next we have propagators, and this is where you specify one or more propagators. This is for context propagation, right? So you have you have that correlation between your traces, metrics, and logs. Then we have a sampler definition. You add this part. This is optional only if you want to do any sampling for your data. And then finally, we have this Python env section. And you're probably looking at this thinking, OK, but there's an env section up top, and now there's this Python env section. So here, this is where you define Python-specific environment variables that you want to include as part of your auto-instrumentation. Now, fun fact, if you wanted to also auto-instrument some Java code, you could add another section here to this instrumentation resource where it would say Java, and then you would have the env section for that. Other fun fact, you can define more than one instrumentation resource. So you can define them in the same namespace or different namespaces. If you want, you can have one giant instrumentation resource for defining the configuration for all of the languages that you want to auto-instrument, or if you prefer, you can have one instrumentation resource per language. Okay, so now the instrumentation resource is basically the configuration for our auto-instrumentation, but we have to do another bit here, which is in our deployment, we have to add this lovely annotation. Now, this annotation basically says to the operator, hey, I want to auto-instrument my application, and I want to use these configurations for that. So if we look at our annotation, it is under the template metadata section of your deployment. In addition, it says, so our annotation is called instrumentation.opentelemetry.io/injectPython. Now, obviously, if we were doing auto-instrumentation for Java, it would be called inject Java. And notice also that we have a value here for the annotation that says true. And this basically says that we are injecting, we're looking for an instrumentation resource in the same namespace as our deployment. Now, you might be wondering, are there other values besides true? Well, absolutely. So we have true, which, as I said, you're looking for an instrumentation resource in the same namespace as your deployment. You can also have false in case you want to have that auto-instrumentation but be able to turn it off if you don't need it. Now, in the case where we have multiple instrumentation resources defined in the same namespace, then you have to go a little bit different and specify the instrumentation name, because what happens is if you have more than one instrumentation resource in the same namespace and you have that lovely annotation that says true, the operator goes, OK, but which one of these instrumentation resources is my configuration? And then we can go fancier still. Our instrumentation resource might reside in another namespace, in which case you would have to say the name of the namespace of that instrumentation resource and its name as part of your annotation configuration. So you would say that in lieu of that true value. That's awesome. Maybe you're going through this and you're like, makes perfect sense, amazing. And then you go and do it and you're like, dude, where's my instrumentation? Ha! And believe me, I've gone through that, so I'm going to share some of the things that I've learned along the way in trying to auto-instrument my code a la operator. So first of all, make sure that your instrumentation resource is deployed. And we can do this by running this lovely command, kubectl describe otelinst-n. And basically, the instrumentation resource in Kubernetes is named OTelInst. So if you do the describe of that resource, hopefully your resource will show up. If it doesn't, then you know that resource hasn't been deployed. In addition, it'll display all the nitty-gritty details about that resource, so you can go through and see if it looks right to you or not. The other thing is we need to check the deployment order of our auto-instrumentation. So as I mentioned, to auto-instrument in the operator, we have to deploy that instrumentation resource, but we also have to do that lovely annotation to our deployment resource. The order in which you deploy these matters. Instrumentation resource has to be deployed first, followed by your deployment. Because what happens behind the scenes? When you deploy your deployment, that little annotation tells the operator, hey, I'm going to look for an instrumentation resource with all my configs. It finds it, and then guess what happens? It creates an init container to inject that auto-instrumentation into your application code. If that instrumentation resource isn't there by the time you deploy your deployment, ship has sailed, instrumentation no worky for you. So how can you check to make sure that that init container has been created? It took me a while to find this command, but this is it. This will basically, for a given pod in a given namespace, it'll list all of the init containers that have been deployed for that pod. So you should see one that is an auto-instrumentation init container for the language that you intend to auto-instrument. Okay, next, check those auto-instrumentation annotations. As we know, in deployments, there are two places where we can define annotations. One in our main metadata metadata section. That is wrong, it will not work. And the other in our template metadata. That is correct, it will work. In addition to that, you need to make sure that we are specifying, first of all, the correct language. If you are specifying inject Python and your application code is Java, guess what? It's not going to work. In addition, as I mentioned earlier, if you set this value to true and you have more than one instrumentation resource in that namespace, the operator is going to be confused. It's going to error out. You're going to get a nice crash loop back off error, and you're going to be super pissed. So make sure if you have more than one instrumentation resource, you have to specify its name in here instead of true. And then another thing to do is check those endpoint configurations. So in your instrumentation YAML, we are checking our endpoint configuration. If you're pointing to another, an OTel Collector that's running in your Kubernetes cluster and it's running as a pod, you have to specify the service name. And if that collector service is running in a different namespace from your instrumentation resource, you have to do a fully qualified service name. So that's the namespace, in my case, OpenTelemetry.svc.cluster.local. Plus, you have to specify that port number, 4317 for gRPC, 4318 for HTTP. But guess what? For Python, it will not work for 4317 because it does not support gRPC for instrumentation. Found that out the hard way too. Now, if you're deploying your collector as a sidecar, this is what your exporter is going to look like. It's localhost 4317 or 4318. Again, Python, only 4318. And finally, if all else fails, turn to the OTel operator logs. This command here will tail your operator logs, and if you're super fancy and can use sed, then look for the word error. Anything that looks fishy in those logs. That's your last resort. Okay, so if you take anything away from this talk, take pictures of the next two slides. I will summarize these lovely troubleshooting tips for you once again. Number one, install that cert manager first before you install the operator fully. Number two, make sure your resources have deployed, your instrumentation resource, your OTel Collector resource. If deploying OTel Collector, make sure those corresponding pods have deployed, right? Your collector pods and corresponding config maps, your target allocator pod and corresponding config maps if you enabled target allocator. Make sure you've checked that API version, especially for your collector, because there are two versions that you can choose from. Check your deployment order for your instrumentation. Auto-instrumentation, deploy instrumentation first, and then your deployment. Next, make sure that those annotations go in the right spot. It's your template metadata that goes for your auto-instrumentation annotations and your sidecar. Check those endpoint configurations, make sure that they are pointing to the correct collectors, correct service names, and check those operator logs for error messages if all else fails. All right, some handy resources for your reference. We have a blog post version of this talk if in case you want to refer back to this. There is a repo where you can check this stuff out. It was actually created for another talk, but it basically has like all the stuff set up for OTel Collector and auto instrumentation. So definitely recommend you check it out. Also check out the OTel Operator Slack channel. The OTel Operator folks are super friendly. They've always been really great about answering mine and Reese's questions, so don't hesitate to reach out. And finally, doing some shameless self-promotions. I have a podcast. The logo was designed by my 16-year-old daughter, and I've had awesome guests on there, including Kelsey Hightower, and Hazel and Marino sitting at the front there have also been guests, and also Reese, so this is why you should check it out. Also, the OTel End User SIG has a docs usability survey. If you use the docs, love them or hate them, we want to hear from you. Tell us what you think about the docs. It helps us improve the docs. Survey is going to be open until the 15th, i.e. Friday this week. And finally, thank you for joining us, and thank you to Reese's cat, Taco, for being our excellent slide model. I laughed my ass off as I was going through these slides because I love the pictures, so thank you so much.
Have time for questions, but if somebody would like to ask you some questions, ladies, where can they find you?
We'll be around.
We'll be around here. Great.
Yes.
We're going to be at Observability Day tomorrow and at the OTel Observatory booth during KubeCon. So
Fantastic. Thank you so much.
Thank you.
thank you.
Okay.